Hi, Dr. Stewart. So this is Ben Gochanour, and today I'm going to walk you through my project 2. So we start out with an abstract and introduction like usual. I chose to use the clerical data set from the textbook. So here we're using several X variables to predict the clerical hours worked in a day at a department store. We have one categorical X variable, that's going to be day of week, as well as several quantitative X variables. Here you can see a listing of the data set as well as a summary of the data set, an initial GG pairs plot of the data that allows us to see both the plots, the scatter plots of all the pairwise combinations of variables, as well as the individual distributions, the univariate distributions. Below, I also plot a correlation heat map, which is just another way for us to visualize the correlation so we can check on potential multicollinearity before building models, which we will discuss in the theory section. I also give a background on the data. The book doesn't provide much information, but I assume that the days were randomly selected instead of 52 consecutive days to allow for independence, as we assume with our model. So then I briefly go into the theory of MLR. Here is the linear equation form, and here is the matrix form. I also discuss how we can estimate the betas, and how this assumes that X transpose X has an inverse, which will not be the case if we have high multicollinearity in our design matrix. I also provide this visual that's used to help us picture what's going on in MLR and what is going on with the betas, the identity matrix, the hat matrix or H matrix, and the Y matrix. And so here I just do a little bit of derivations about what the H is and all the properties of H, including it being symmetric and idempotent, that allow us to prove many of the things we prove with multiple linear regression. I also focus a lot of my time in the theory on the stepwise regression and the AIC, given that this is something I'm interested in and that we don't have time to fully cover in class. So I discuss what it is and sort of the discussion surrounding it. Next, and probably most importantly, I get to the model building. Here I'm fitting a simple naive model with all the variables, and then below I'm fitting a stepwise model that's going to remove some of the independent variables and find us the optimal model. Here is R squared, and I provide the interpretation there. Now here is the model assumptions. Namely, we assume that the model errors are distributed normally with mean 0 and constant standard deviation. So here we plot the Shapiro-Wilk test to examine the idea of normality, and because this p-value is greater than 0.05, we fail to reject the null hypothesis that the errors are distributed normally. We also take a look to see if the variance is constant. So here's a plot, and it exhibits the random scatter we'd like to see. If we saw a fan shape or something here, we might be concerned that the residuals are not constant, but this plot appears to provide good evidence that we can proceed. Here we just calculate to verify that epsilon indeed has approximately mean 0. Also, as I noted above, we're assuming the data has the appropriate independence property and that the days were selected with randomization, and so the hours worked in one day does not depend on the next. Now, after some of this introductory analysis, we'd like to provide some estimation and further data analysis. So here I provide the interpretations for all the beta variables. We notice these beta variables in the middle or towards the beginning are categorical, and so I provide the appropriate interpretation where it's the day of the week minus Friday, since Friday is our baseline day. I also provide some confidence intervals using the conf_int function in R for all of the beta parameters. Also check on some outliers here. We know that the cutoff value for a significant outlier is typically 4 over n, where n is the sample size. So I've plotted that line here, and we see that there are a couple above this point. Given that I have no reason to doubt the validity of these observations, I'm not going to remove them, but it is good to take a look at this and could be considered in a future study. Here we do some prediction. So we use the predict function. And importantly, we should note that this is predicting a future value. So this is based on a future value where the independent variables take on the values they do in our first observation. So we get this confidence interval here and the appropriate interpretation. Of course, this is going to be very useful for decision makers who are trying to use our regression to predict certain things. Here we're going to plot our model. We use that same RGL plot that we've been using a lot to give us a nice plane here where we have returns and miscellaneous as our X and Y, and then our clerical hours worked, which is our Z, of course, and we have this plane here. Finally, we're going to get to our conclusion, which basically says that yes, we do have enough data to adequately model clerical hours worked. It also discusses the implications of this study and potential follow-up studies that would seek to understand more department stores or even more retailers in general. So this was my project 2, and thank you for listening.